Welcome back to the 13th chapter of Multibody Dynamics using Altair HyperWorks MotionView MotionSolve. Till now, we have learned how to build mechanisms, apply joints, forces, motion, contacts, etc. And we've also learned regarding the trending technological developments in multibody dynamics using flexible bodies. Now, it is time to put in all that we have learned so far in building more complex and parametric systems. The subsequent chapters will help you in building a full model using a modular building approach and setting up parametric relation between the various parameters involved in the simulation. You will learn to appreciate the usefulness of these chapters once you go on to build complex models which are a combination of two or more subsystems. From chapter 13 to 15, you will build a simple car model from various systems of a model that you will be either creating or importing and attaching to the rest of your model. Along the way, you will also learn regarding the various building blocks of the MotionView models. In this chapter, we will discuss the following topics: container entities, creating, importing, and exporting systems, and the spring damper entity in MotionView, which we'll be using in the exercise. Now let's move on to the first topic in this chapter, where I will be providing an overview on the container entities. MotionView basically encourages a modular model building approach. This means that various entities can be grouped into containers and arranged into models, basically into a systematic collection of different subsystems. This allows a model of any level of complexity to be systematically arranged in a hierarchical manner. This organized approach helps the analyst and also his or her fellow analysts to work on a certain complex model in an organization simultaneously, though it takes some initial efforts to plan and organize the model in the right manner. The major benefits of using this particular type of approach includes the following. It provides a clear understanding of various subsystems or the assemblies involved in a complex system. Any person in your team can easily identify the content in your model, no matter how complex your model may be, just by visualizing the model tree in the model browser. The second advantage is that if the model is not running in the correct manner, that is, if there are any issues associated with the model, these container entities can be deactivated or activated in just one click, which is really useful while debugging a model. Another major advantage is that these subassemblies can be reused in different models. The container entities can be exported to a definition file and can be easily reused in a different model that requires a similar subsystem present in your model. For instance, take an example of a parking brake mechanism, which consists of several components, joints, forces, and other entities. This system definition can be exported to a system definition file and can be reused multiple times in different vehicle models. There are basically three types of container entities: system, assembly, and analysis. Systems are basically intended for modeling mechanisms. Assemblies are intended for modeling mechanisms using external files for reference. And analysis are intended for performing analysis but may also include modeling entities. But in this current chapter, we will focus on the systems. System may contain any other modeling entities like points, bodies, forces, joints, etc. It can be reused as many times as you like. A system can be a child of another system, or other container entities. The image below shows a simple model of a hatchback door of a car. The model has been arranged into a system called as the hatchback system, which in turn has two subsystems, the door system and the damper system. The door system contains the door along with its hinge joint, and the damper system contains the damper bodies along with their joints, the ground and the door. These systems can also be connected to other systems via attachments, which you will be learning in the upcoming chapters. The parent or the subsystems created can be easily reused for other applications as per the requirements of the user. Okay, now let's go to the MotionView graphical user interface to learn how to create, import and export systems. So systems can be created in two ways. One way is by right-clicking on this particular icon, which brings up the Add System or Assembly dialog box. The other way of getting to this particular Add System dialog box is by right-clicking on the model, going to the Add option, and then clicking on this System or Assembly. So it takes you to the same Add System or Assembly dialog box. And then you can click on the System Radio button and then click on the Next button. So when you do this, this indicates that the parent system is going to be your model, which is the system that is created by default when you start your MotionView. And then you need to define the variable name, the label name, and the definition name of the system that you'll be creating. So please note that the variable name can only be changed during the creation of a system and cannot be changed during the model building process, whereas the label name can be changed during the model building process. The definition name basically defines the single template of the system, which can be reused multiple times to create multiple systems. Also, please note that the system is always created within the parent system that has been selected. So say in case you have another system, say model, and a second system called as model A, then you need to select which particular parent system that you want to assign the subsystem to. So in this particular case, we have just the model as the parent subsystem. Okay. After giving the appropriate variable names, label name, and the definition name, you can click on OK, and you can see that this particular system called as system 0 is created under the parent system model. Okay, now let's move on to the importing and exporting of systems. So when you create a particular system, you can see that there is this import export tab in your systems panel. So you can, for importing a system, you can click on the import radio button and you can select a particular file and then say open. Okay, and then click on import. So it's that easy to create or to import a particular system. Next, to export a particular system, you need to click on the export button and then select the required system and select the required system and then click on quick export. The system can also be exported with or without the model topology and with or without property data. So these options allow you to separate the data from the topology if desired. So that can be done by enabling and disabling this particular checkbox for the property data. Okay, now let me go back to the presentation. So we've covered all these topics in the graphical user interface. Now coming to the last topic of this chapter, which is regarding the spring damper entity And I'm explaining regarding the spring damper entity because we'll be using this in the exercise. The spring damper panel allows you to create and edit the properties of the spring damper force elements. So it will be better if I explain this by using the graphical user interface. So let me switch back to the Motionview graphical user interface. And here you can find the icon for the spring damper entity. So you can right click on this particular icon and it brings up the Add Spring Damper dialog box. So here you can give the label name for your spring damper and you can also give the variable name. So as I mentioned earlier, the variable name can only be edited during the creation of this particular entity and cannot be changed during the model building process. And you can create two types of spring damper entities. One is the coil spring and the other one is the torsion spring. The coil spring generates a translational line of action between 2 points on the two bodies, that is a function of the distance and the relative velocity between the 2 points, whereas the torsion spring produces a moment between two bodies, that is a function of the relative angular displacement and the relative angular velocity between the two bodies. So first, let's say we select coil spring. Okay, and you can also create explicit graphics for this particular coil spring that you're creating. And you'll understand this in more detail when we do the exercise for this particular chapter. Okay, so then just click on OK. And then this is the spring damper panel. So you can see that the spring damper system that you've selected is the coil spring. So you'll have to select body 1 to which the spring damper is attached. And then you'll have to select the body 2 to which the spring damper is attached, and then the first point on the first body to which a spring damper is going to be attached, and then the second point on the second body. So if you change this to torsion spring, you can see that these options change, wherein you'll have to specify the body 1 and body 2 to which it will be attached, and also the origin point to which the torsion spring damper will be attached, and also you need to specify the alignment axis. Either you can specify a point or a vector which can be along global x, y, z. And here in the properties tab, you can specify the stiffness and the damping ratio for your particular spring damper entity. Okay, and in the preload, you can specify the preload or the free angle in case of the torsion spring damper. But if you change it to coil spring, then you can give the preload value or a free length or a combination of both. Now let me switch back to the presentation to explain this preload in detail. So preload is basically the initial force or the torque in the spring in the model position. The total preload, which is FP, is given by this particular equation, which is equal to P, which is the preload value, plus stiffness into the initial length minus the final length of the spring. Okay, so MotionView creates a coil spring damper with a default value free length as the distance between the two endpoints that you've specified while creating your spring damper entity. Okay, so you'll understand this in more detail when we do the exercise for this particular chapter. Okay, so now it's time to move on to the demo on chapter 13. Thank you.